Have you ever wondered how insulated cups, mugs, or water bottles keep your morning coffee hot or your morning smoothie cold? Today is day 112 of learning something new every single day without AI because not everything needs to be automated. And today I learned how your favorite go-to mug or cup keeps your drinks hot and cold. It's not magic, it's just science. All the main companies like Yeti, which is the one that I use a double-walled system, which means that there's a wall on the inside that stops the heat from getting out and a wall on the outside that stops the heat from coming in. But then we have to worry about what goes in between the two walls so that the heat just doesn't transfer between the two. And so we need some kind of insulation in between the two walls to stop the spread of heat from the inside to the outside and vice versa. And there's four main types of insulation. That's air, foam, vacuum, and copper insulation. The article that I'm reading swears by the vacuum insulation, which is just creating like a vacuum pulling all the air out between the two walls. But if you use Yeti, they use a foam insulation. So I think any insulation really works. I seem to think that the Yeti works pretty well. This is not sponsored, by the way. But now let's look at the science. There's three different ways that heat can be transferred. That's convection, conduction, and radiation. Heat conduction takes place when two different objects are touching and they're at different temperatures. They have to find an equilibrium point. Convection takes place when fluids are heated or cooled from an external source. And radiation takes place when a hot thing emits heat waves from its source. An example of this is the sun. Conduction and radiation are eliminated by the double wall structure because for conduction, no liquid is going to be touching whatever's inside. And for radiation, no waves are going to be emitted outside of the bottle. And finally, convection is eliminated because the insulation does not allow an external source to change the temperature of the internal liquid.